In this lesson, I want to talk about the keywords we've added to our source code in several spots. The keywords I'm referring to are the async keyword, the await keyword, and the task of T keyword. And you see all three of these in the get Flickr images method in our Flickr image class. So these keywords are newly added to C# 5.0, and they're generally referred to as the new async feature, which is short for asynchronous or asynchronicity or asynchrony. Okay, I've heard all three used. In a nutshell, this feature is a simplified way of improving the performance of the app and making it more responsive to the end user without the complexity of writing a multi-threaded application. If you call a method in the Windows Phone API or some other library that supports async that could potentially take a long time, the method will say, essentially, I promise to get those results to you, or I promise to do that work as soon as possible, so you go on and do your business, and I'll let you know when I'm done. So then the app can continue executing and even exit out of method contexts, and at the point when it actually needs the results, then it can stop there. But other work can be going on, and it doesn't have to be waiting on other code that might take a long time to execute. Okay? So another word for this in computer programming terminology is a promise. Under the hood, whenever you compile this source code, the compiler picks apart the source code and it implements a complex series of statements in the intermediate language to allow asynchronicity to happen flawlessly, and it does it usually without the use of multiple threads. Okay, so when is async? When is it best used? It's for operations that have a high degree of latency but are not compute intensive. All right, so for example, we want to retrieve data from a web API like we're doing with the, right here, this getString async method. Now before async, we'd make a call out to the web server, and that could take a long time. I mean, your phone has to connect to the internet, it has to make the call, the server on the other side has to determine the results and pass it all that information back. So that could take a second, maybe 2 seconds, maybe a worst case scenario, you got a bad connection on your phone or whatever the case might be, it could take 3 seconds, which even a second is an eternity in computing. But the phone's processor is just sitting around, it's not busy, it's just waiting for an answer, right? So this is known as I/O bound. I/O means in, out. So things like information in or out from to and fro the file system, the network, the camera, and so forth. They involve I/O bound operations, and they're good candidates for async. In fact, the Windows Phone API designers decided to bake in async to all I/O bound operations, forcing you and I, the developers, to keep the phone responsive to the end user by forcing us to use async functions like getString async. Here we have, and when we called out on HTTP, right, using the HTTP client class. Contrast that to compute-intensive operations such as a photo filter app that takes a large image from the camera and then it runs complex mathematical algorithms on the phone's CPU to change the colors or the position of each pixel in the image. It might be millions of pixels that it has to process, and that could take a long time too, but in that case, the phone's processor is hard at work. It's not sitting around waiting. It's actually breaking a sweat trying to process all of that data. That type of operation is known as CPU bound, and that's not a good use of async. In that case, you'd want to consider a background worker which helps you manage the threads on the Windows Phone platform. Now, if you're developing in .NET, you might prefer working with threading via the task parallel library or the TPL library instead, or you could even revert back to managing threads manually, which has been an option from the very earliest versions of .NET, but that's not an option on the Windows Phone. So understanding multi-threading, parallel programming, the task parallel library, and even background workers on the phone are way beyond the scope of this series and especially this lesson. It's a very large topic, and I'm not going to lie to you, it often makes my head spin when I try to study it. But if you want to learn a little bit more about async, specifically how it applies to the Windows runtime, if you're building on the Windows RT API, and you just want to understand async in general, this is a great article to start with. Actually, it's a video that I recorded. It's called Working with Async Methods in the Windows Runtime. So check that out. And you might also want to read in the comments below that video where I further explain this idea. That should be sufficient for now. But back to the topic at hand. Async is for those common occasions where you have a blocking operation that's not compute intensive, such as is the case here where we're waiting for the HTTP client.getStringAsync operation to complete. In this case, you use the await keyword, which says, I'll get back to you when I'm finished. So then the thread of execution can continue on to the other lines of code until they absolutely have to have the results of the operation. Now in our case, since the very next line of code we're attempting to use Flickr result and we haven't gotten Flickr result yet, we're going to pretty much be waiting on this line of code no matter what. So it maybe doesn't give us that, in our case, that really fast speed improvement because we can't do a lot of operations after we make the call out via HTTP. However, while we are going out and making that call, other things on the phone can be happening, so we're not locking up the user experience. So any method that uses an awaitable method like we have here, this getStringsAsync, it must be marked with the await keyword, and therefore we also have to mark the method itself that contains it with an async keyword. And if it's supposed to return a value, like in our case we're trying to return a list of Flickr image, then that return value has to be wrapped in a task of T, like we did here, where we wrapped our list of Flickr image with a task of T around it. Okay. Now, if the method happens to be void, then it merely has to be marked async void in the method signature. You don't have to worry about the task of T stuff. Okay. But that essentially means that any method that calls our method can continue executing until it absolutely needs this list of Flickr image. So, therefore, take a look at the search results.xaml.cs. If you take a look here, we are calling get Flickr images. Since it returns a task of T, a task of list of Flickr image, then we have to await that call, and therefore we have to mark our search results loaded event handler method as async as well. However, since search results loaded is what you would call a topmost method because it's an event handler that gets fired off by during the execution of the app, the async calls end here. All right. So again, remind me why we're doing all this. Well, it's in hopes of making our app more responsive. This operation should not be blocking the phone's processor from taking on other tasks, or the phone itself from answering a phone call or running background tasks on behalf of other apps. It won't prevent the user from selecting any of the hardware buttons on the phone and getting an instant response. All right, so to recap, the big takeaway in this lesson is what async is and how it works and what scenarios it was designed to address, and its overall purpose, and that is to keep the phone and your apps as responsive as possible during long-running I/O-bound operations. Okay, so we'll pick up the development of our app in the very next lesson. We'll see you there. Thank you.